Greetings, everybody. Nick and Alex here to enlighten you all regarding IVT. IVT stands for Intermediate Value Theorem, which states if f of x is continuous on a closed interval from a to b, and if k is any number between f of a and f of b, then there's a number c where f of c is k. So in English, this means that between 2 points, there are two y values, and on some function where there are no holes or asymptotes, that there must be some y value in between the two that the function must achieve before it reaches its endpoint. So let's put some numbers behind this. So let's say that we have a point 2, 2 and another point 5, 5. Then there must be some point between these two on the interval 2 to 5 that there's some x value where f of x could be 4, or there could also be an x value where f of x is 3. And this is the main concept of IVT. Regardless of what the function looks like, through IVT we can say that the function must equal some intermediate value between two extremes. However, IVT does not let us actually calculate this value. It is an existence theorem.
So we can also find that if a function has a solution, so for example, we'll look at the function x cubed plus 3x minus 2. In this situation, we can find 2 points on the graph, or we can use 2 points to find that there's a solution on this function. If we plug in 2, we get that f of 2 is 12. If we plug in negative 2, we get that f of negative 2 is negative 16. And because the function is continuous, we can see that there is a point that would travel through the x-axis, meaning that the function is equal to 0. However, this doesn't always work. So if we were asked to find a real number that satisfies the condition that x is equal to its square plus 5, we can rearrange that equation to x minus x squared minus 5 equals 0. In order to find a number that satisfies this condition, there must be a number c that makes the function equal to 0. If we plug in 10, we get that f of 10 is equal to negative 95. If we plug in negative 10, we get that f of negative 10 is equal to negative 115. Because these are both negative numbers, we can't prove that there's a number that travels through the x-axis. Thus, we can't prove that there's a solution to this.
So let's add some real-life applications to this. Let's say there's an AP Calculus BC student named John that weighs 135 pounds at the start of junior year. But when the year ended, he, say, weighed only 150 pounds. Since weight is continuous and not sporadic, we can use IVT to determine that during his junior year, John must have weighed some value between, so we can say he weighed 142 pounds during the year. However, this doesn't always stay true. If John loses and gains weight cyclically, then we cannot determine exactly when he weighs 142 pounds, because there can be more than one instance that he weighs that weight. So here's another application. In the movie Back to the Future, Marty McFly must achieve a speed of 88 miles per hour in the infamous DeLorean in order to go back in time, according to Doc. After 1 second, we figure that he must have reached a speed of 40 miles per hour because he must have been slamming that pedal pretty hard. Then, depending on his final speed, we can determine if he succeeded. And if we know that his final speed was 100 miles per hour, we can conclude that his time travel was unsuccessful because we know how fast he was going after and therefore we know that the flux capacitor malfunctioned because we still see him in our time, and he's not back in time. And thanks for watching IVT with Nick and Alex.